For decades, scientists had been searching for something mysterious, a particle so fundamental that without it, the entire universe would be completely different. This elusive entity is called the Higgs Boson. Discovered in 2012 at CERN's Large Hadron Collider, the Higgs Boson is often nicknamed the God particle, a term physicists don't love, but one that certainly caught the public's imagination. But why is it so important? And how does a single particle play such a huge role in the universe? To understand that, we need to step into the strange world of particle physics. In the Standard Model, the blueprint for all known particles and forces, everything in the universe is made of a small set of elementary particles. Some have mass, some do not. For example, photons, which carry light, have no mass. But particles like protons, neutrons, and electrons do. And for decades, one question haunted physicists. Why do some particles have mass while others are massless? In the 1960s, a group of scientists, including Peter Higgs, proposed a radical solution. An invisible energy field fills the entire universe. This is the Higgs field. It's everywhere, inside galaxies, between stars, even in the space between atoms. Particles that interact strongly with this field gain mass, while those that barely interact remain massless. Imagine the Higgs field as a kind of cosmic syrup spread across the universe. If a particle tries to move through it and gets stuck or slowed down, it gains mass. If it slides through effortlessly, it remains massless. Without this field, particles would zip around at the speed of light and could never form atoms, molecules, or life. Now, how do we know the Higgs field exists? In quantum physics, fields have particles associated with them. For the electromagnetic field, the particle is the photon. For the Higgs field, the particle is, yes, the Higgs boson. Detecting this particle would prove the field is real. But there was a problem. Finding it was incredibly difficult. The Higgs boson is unstable and exists for just a fraction of a second before decaying into other particles. To detect it, scientists needed to recreate the extreme conditions of the early universe, temperatures and energies far beyond anything on Earth. That's where the Large Hadron Collider, LHC, came in. The LHC is the largest machine ever built. 27 kilometers of superconducting magnets buried under the French-Swiss border. Inside, protons are accelerated to nearly the speed of light and smashed together. These high-energy collisions briefly recreate the conditions just after the Big Bang. Out of this chaos, new particles appear. Sometimes, one of them is a Higgs boson. After years of experiments, in July 2012, scientists finally saw the unmistakable signature of the Higgs boson. It was a triumph for physics, a missing piece of the puzzle found after nearly 50 years of searching. In 2013, Peter Higgs and François Englert received the Nobel Prize for their work. So, what has the Higgs boson taught us? First, it confirmed that the Higgs field exists, explaining why matter has mass. Without it, the universe would be a featureless soup of massless particles. No stars, no planets, no people. Second, it validated the Standard Model, which has predicted countless phenomena with astonishing accuracy. But the discovery also opened new mysteries. The Standard Model, as powerful as it is, doesn't explain everything. It doesn't include gravity, dark matter, or dark energy, mysterious forces that make up most of the universe. And the Higgs boson itself could hold clues to these deeper questions. Some theories suggest it could interact with hidden particles, revealing entirely new realms of physics. Today, scientists at CERN continue to study the Higgs boson with increasing precision, trying to measure its properties, its mass, lifetime, and interactions. Any deviation from predictions could hint at physics beyond the Standard Model. Maybe it will point towards supersymmetry, extra dimensions, or something we haven't even imagined yet. In the end, the Higgs boson is more than just a particle. It's a key that unlocked a door to the fundamental structure of reality. Its discovery shows the power of human curiosity, collaboration, and perseverance. It reminds us that the universe still holds secrets, and that we have only just begun to uncover them. We may never see the Higgs boson with our eyes, but every atom in our bodies owes its existence to the invisible field it represents. Without it, there would be no us to ask the question, why is there something rather than nothing?